Alright, this is the class notes from 11.4. I'm talking about arcs and chords and how those relate. So first we have a definition called a perpendicular bisector. So what that is if a diameter of a circle is perpendicular to a chord, then the diameter is the perpendicular bisector of the chord. What that means, if we have a chord on a circle, so on this circle, DE, that segment is a chord. If a diameter hits that chord at a 90-degree angle, like shown in the picture, then the diameter bisects the chord, meaning it cuts the chord in half. So each of those halves of the chord have to have the same length. They must be congruent. Again, the diameter has to be perpendicular, and if so, then it bisects the chord. So let's look at example 1. Find the length of BD. So I'm going to highlight BD on the circle. BD is a chord, and we can see the diameter, AF, makes a right angle with my chord. So thus, it is bisecting my chord, meaning that both of the sides, or both halves, have to be congruent. If this side is 5, the other side has to be 5. If both sides are 5, to get the total length of BD, just double that. 5 plus 5 gives us a length of 10 for BD. Alrighty, next box. Our second property for today. In the same or incongruent circles, so two circles exactly the same size, if two chords are congruent, then their corresponding minor arcs are also congruent. Same thing works backwards. If two minor arcs are congruent, their corresponding chords are congruent. So looking at my picture to the right, if the arc going from A to B is congruent to the arc going from D to C, then the corresponding chords have to be congruent. So we have an arc from A to B, but we also have a chord from A to B. Again, we have an arc from C to D, and we have a chord from C to D. If the chords are congruent, the arcs are congruent, and vice versa. That's what that means. So, in example 2, we have to find the value of x. We can see that the chord from P to Q and the chord from S to R are congruent, which makes these two arcs also congruent. And again, when we're finding the measure of arc PQ, that means the angle that is inside of there, inside the circle. So, if the measure of PQ has to equal the measure of SR, then we know that x has to equal 60 degrees. Looking at part B, again we're trying to find the value of x, so we're trying to find that chord there, AB. We can see, however, though, that these two angles inside here are congruent, meaning that the two arcs, AB and arc DE, are congruent. We can also see when it has that 70 degrees on the outside of the circle, that just means that angle inside the circle that corresponds with that arc is 70 degrees. So both those angles are 70 degrees. They're congruent. So if the arcs are congruent, then the chords are congruent. Thus, x has to be congruent to this side here, which is 3. Alright, go ahead and pause the video, try the checkpoints on the next page on your own, and then unpause and check your answers. Alrighty, so see how you did. In example 1, if this angle here is 90 degrees, we know the second angle has to be 90 degrees. If the angles are the same, that tells us the arcs are the same, which tells us that the chords have to be congruent. Thus, x plus 2 has to be equal to 5, which gives us x equals to 3. On number 2, since the diameter cuts through this chord at a right angle, then the two halves of the chord must be equal, so they must both be 15, making the whole length of SR 30. Alright, last problem. Part A, explain why arc AD is congruent to arc BE. So we're looking at these two arcs here, AD and BE. Now we can see that the chord from A to D is 5, and the chord from E to B is 5. So if the chords are congruent, then the arcs are congruent. So we could write this as because the chord AD, which is we write a segment, is congruent to the chord EB. which makes the arcs congruent by the property we talked about today. Alright, part B, we have to find the value of x. So because we know that the chords AD and EB are congruent, we know that their lengths have to be equal, so we can set them equal to each other. So 15x minus 40 has to equal 10x plus 10. I'm going to subtract 10x from both sides to get all my x's on one side. So I have 5x minus 40 equals 10. Move over the 40 by adding. 5x equals 10 plus 40 is 50, so x has to equal 10. So there's the value for x. But to find the measure of arc AD, I have to plug that back into this equation here. So I will have 15, and then for x I'm going to plug in 10, minus 40. So 10 times 15 is 150, minus 40 gives me 110 degrees, and that is the measure of arc AD. Now we know the measure of arc BE must be congruent, so it must also be 110, but let's try plugging in 10 to our equation to double check. So I'm plugging that in here. So I plug in 10 into my equation, 10 times 10 plus 10, 10 times 10 is 100, plus 10 does in fact give me 110 degrees. So it works out that they're congruent like we wanted. Alright, last part, find the measure of BD. So we're finding this arc here. We don't know anything about this arc. We don't have a corresponding arc. So how are we going to find it? Well, notice that we know the measure of all the other arcs that make up the circle. We know this arc in here, this angle is 110, this angle is 110, and this angle here, we know, is 40. So we know all of the angles in the circle add up to 360 degrees. So we can add 110 plus 40 plus 110 plus what we're looking for, the measure of BD, have to add up to 360. We add this together on the left and we get 260 plus the measure of arc BD equals 360. Thus, the measure of arc BD must equal 100 degrees. Alright, that is it for section 11.4.